After years of planning and global collaboration, Britain is about to reveal its most ambitious warplane yet, the Tempest. This sleek sixth-generation jet blends stealthy design, powerful engines, and advanced AI to push the boundaries of modern air combat. Developed with partners from Italy, Sweden, and Japan, the Tempest brings major upgrades in weapons delivery, pilot support, and unmanned drone coordination. But what secrets lie beneath its smooth exterior, and how might it change the future of aerial warfare? As global powers race to build sixth-gen fighters, the UK is stepping up. While the US is led with jets like the F-22 and F-35, and China's J-20 and Russia's Su-57 have joined the scene, Britain refuses to be left behind. The Tempest project is designed to rival or surpass them, boasting cutting-edge engines, AI co-pilots, and classified weapons tech. It signals the UK's return to the forefront of fighter innovation. The name Tempest holds historical weight. During World War II, the Hawker Tempest replaced the Typhoon and helped fight back Nazi air forces. Now, as the RAF prepares to retire the current Eurofighter Typhoon, the Tempest name returns, this time representing the future of flight. The initiative began shortly after Brexit, as the UK sought to strengthen its defense sector, generate high-tech jobs, and secure its economy. With France becoming the EU's sole nuclear and aerospace leader, the UK launched its own fighter program to remain competitive and independent. In the 2015 Strategic Defense Review, the UK committed to building a next-gen aircraft under the Future Combat Air System, FCAS. By 2017, the UK had teamed up with Japan, forming a joint fighter development team. In early 2018, Defense Secretary Gavin Williamson announced a new aviation strategy, and by July's Farnborough Air Show, he unveiled a full-scale Tempest model. The Tempest features stealthy delta wings and twin outward-angled tail fins. BAE Systems leads the overall design. MBDA handles weapons. Leonardo UK focuses on sensors and electronics, and Rolls-Royce is building the next-gen engine. The UK has pledged over $2.6 billion to bring the Tempest from concept to flight by 2025. At first glance, it may resemble other modern jets, but its real advantage lies beneath. The aircraft uses a modular plug-and-play system. Bays and mounts allow for mission-specific configurations of sensors, fuel, and weapons. This flexibility allows upgrades without full redesigns, keeping the jet future-proof. Even its construction is high-tech. BAE plans to 3D print up to 30% of its structure. This method, using metal powders, cuts waste, saves time, and allows for intricate internal designs that reduce weight and boost strength. With international collaboration, massive funding, and advanced production techniques, the UK is building more than just a jet. It's shaping a future-ready platform. Tempest is designed to evolve, adapt, and dominate for decades, keeping the Royal Air Force at the cutting edge of air combat. The Tempest fighter sports a subtly raised rear fuselage that accommodates smooth S-shaped air ducts hidden behind twin engine inlets. These ducts, neatly blended into the body, reduce radar and heat-seeking visibility by hiding bumps and hot spots. This sleek shape and tucked-away heat sources help the jet stay off enemy sensors, just like other stealth aircraft. All fuel and weapons are stored internally, not on external pylons. This keeps the jet's outline clean and reduces radar signature, though increases empty weight. Engineers aim for a balance between the Eurofighter Typhoon and F-22 Raptor. While internal storage adds mass, the Tempest will offset it with powerful engines to maintain speed and agility. The jet will require a huge amount of electric power to run advanced sensors, weapon systems, and cooling tech that hides its heat signature. Rolls-Royce is developing engines that deliver high thrust while running at extreme temperatures. This improves fuel efficiency and lets the jet fly longer or carry more without burning too fast. Efficient power and heat management systems will steer electricity where needed and keep systems cool. Rolls-Royce is targeting 1 megawatt of onboard power, 10 times more than current Typhoon engines. That's enough to support powerful radar, EW gear, and cooling systems. To achieve this, they're embedding the starter generator directly into the engine core, skipping the old gearbox setup. The E2SG embedded electrical starter generator program began in 2014. Initially, a starter generator was installed inside a jet engine, By 2017, the team added energy storage and smart controls to manage power flow more efficiently. Upcoming improvements will refine power loops and thermal controls to match real flight needs. Stealth fighters often show up in infrared, so turning the engine into both a power plant and a cooling system is key. Smart controls will shift energy between thrust, electronics, and heat dissipation. This integration makes the Tempest better at hiding from heat-seeking systems than older jets. By combining a bulged fuselage, hidden ducts, internal bays, and smart engines, the Tempest becomes stealthy, agile, and hard to spot. It pushes the boundaries of power, stealth, and speed beyond what current fighters offer. Rolls-Royce new future jets would need more electric power than traditional engines could provide. Their E2SG program replaces a heavy, complex gearbox with an internal starter generator built right into the engine shaft. This unit starts the engine and powers the aircraft during flight, saving space and reducing failure points. In Phase 1, they prove it could start an engine without a gearbox. In Phase 2, 2017, they added energy storage and custom software to manage power flow. The system could then balance electricity across systems, even during high-demand moments like powering sensors or cooling stealth coatings. Power could come from the generator, the battery, or both, keeping everything running smoothly and reliably. The third phase, launch around 2020, pushed the Tempest design further. Rolls-Royce is building two separate electric loops inside the engine, like backup generators, to boost power. They're also upgrading thermal control, using advanced heat exchangers and smart materials that absorb or release heat based on flight conditions. All of this connects to a central power management system that constantly adjusts engine speed, power output, and heat flow. This lets the engine power high-energy lasers and multiple sensors at once, without overheating or increasing weight. Meanwhile, Leonardo UK is developing the Tempest's cutting-edge electronics across 4 key areas. First, they're designing radar and electronic warfare systems with digital beamforming, allowing the radar to track multiple targets or zoom in on one, without delay. They're also building a wideband RF sensor that shifts modes to detect threats like enemy jets or ground radars. Second, they're integrating radar, IR cameras, electronic signals, and drone data into a single system. Third, pilots will use AR/VR overlays in their helmets or displays, showing flight paths, targets, and warnings right in their view. Lastly, an AI co-pilot will help make fast decisions, reacting quicker than humans, and taking over instantly if the pilot blacks out under high G-forces. Combining Rolls-Royce's power tech and Leonardo's smart avionics, the Tempest promises to be a next-gen fighter. Its engines will power lasers, sensors, and cooling systems, all from a lighter design. In the cockpit, AI helps pilots stay ahead in combat. This blend of power, tech, and AI aims to keep the UK's Air Force at the cutting edge for decades. To dominate future skies, the Tempest will need strong firepower and adaptive systems. One idea is to fit it with 6 to 8 missiles stored internally, keeping its shape stealthy, though official numbers haven't been confirmed. For reference, today's Eurofighter Typhoon usually carries 4 to 6 long-range missiles, 2 to 4 short-range ones, a 27mm Mauser cannon, and up to 3 fuel tanks. Future Tempests may use joint UK-Japan weapons like the JAM missile, which combines Japan's advanced seeker tech with MBDA's Meteor ramjet motor, creating a fast, long-range, precision air-to-air missile. The Tempest could also carry next-gen cruise missiles to hit ships or land targets, replacing current Storm Shadow/Scout missiles. These modern weapons fly low to avoid radar and strike from long range, ideal for stealthy, high-impact missions. Perhaps most futuristic, loyal wingmen, drones fly in swarms alongside Tempest jets. These unmanned craft will scout, jam radar, fire missiles, or act as decoys, handling dangerous missions while protecting pilots. As jets grow more expensive and complex, these cheaper, expendable drones offer more options and less risk for commanders. To speed up Tempest development and spread out the costs, the UK brought in global partners. At the 2020 Farnborough Virtual Air Show, then Defense Secretary Ben Wallace announced 7 more companies had joined the core team, forming the Tempest Consortium. These included GUK, a GE and UK venture, GKN, Collins Aerospace, Martin Baker, Kinetic Weapons Tech, Spirit Aerosystems airframes, and Thales UK sensors/electronics. Together, they're working on over 60 new technologies, from engine parts and stealthy airframes to AI systems and next-gen cockpit displays. Each company tackles a different area, helping reduce costs and speed up delivery. All this missiles, drones, advanced cruise weapons, and global teamwork targets one goal: ensuring Tempest and its wingmen lead air combat into the 2030s and beyond. The UK is combining proven British expertise with fresh global input to build a smart, stealthy, and powerful fighter. In December 2020, the UK signed an agreement with Italy and Sweden, defining each country's tech, funding, and R&D roles. Soon after, Japan joined in, agreeing to co-develop a test bed and a prototype radar system called Jaguar for Tempest. The engine test rig will simulate extreme flight conditions, while Jaguar will test advanced radar modes that shift quickly between search, tracking, and jamming, key for 6th-Gen fighters. Tempest development isn't cheap. The UK expects to spend over $8.3 billion, still far less than the U.S. Air Force's $29.5 billion for the B-21 Raider stealth bomber. Despite the high cost, speed is a priority. In July 2022, officials announced a flying prototype would debut by 2027. Engineers at BAE Systems in Preston are already building and testing key components. Early flight trials will gather vital data on aerodynamics, stealth, engines, and systems before full production begins. The RAF aims to bring Tempest into service by 2035. That gives time to train pilots, upgrade infrastructure, and develop tactics for a fighter that will use stealth, advanced sensors, AI, and unmanned drones. By working with Italy, Sweden, and Japan, the UK gains access to Italian materials, Swedish radar tech, and Japanese engine know-how, all while keeping costs down. With this teamwork, Britain hopes not just to keep up, but to lead in creating the future of air combat.